Okay, so today we're going to talk about finding average rate of change, and I'm going to do this in a video so that you can watch this as many times as you need to feel really good about it. We have two assignments. One is find the average rate of change for f of x, that's that graph, from -2 to 4. And the second assignment is to find it for g of x, that's this equation, from -2 to 1. And so average rate of change, you guys remember rate of change for a line is just rise over run, how far it changed in y over how far it changed in x. And so we're going to use that same idea to find it for a curvy misshapen line too, because even though it's going all over the place and I can't find, the rate of change is going to be different every which way, the average rate of change would really be just the same thing as the slope of the line that would connect these 2 points that we're interested in. So if we're going from -2 to 4, in order for me to do that, I'm going to need to know the coordinates of this point. Well, it's a graph. I can read it. I'm really good at this. This is -2, 1, 2, 3, and my coordinates for that point are up there. And then this point, it starts x coordinate is 4, y coordinate appears to be -1. So all I'm doing at this point is just reading the graph to find out what those points would be. Then, to find rise over run, we do the same thing we always do, which is we think about delta y, the change in y, over delta x. Well, if the y changed from 3 all the way down to -1, I know that it dropped by 4. So in my head, I could just think 3 all the way down to 1 is -4. But I could also do it more explicitly. I could take the final, -1, minus the initial, which is 3. And actually, I'm going to write this out explicitly. So what we'll do is we'll say that the change in y is just y final minus y initial over x final minus x initial. So that would be -1, the final y coordinate, minus 3, the initial y coordinate, all over 4, the final x coordinate, minus, and then -2, the original x coordinate, which once we do this math, you're going to see that it ends up being -4, which makes sense. From 3 to 1 is -4 down. And 4 minus -2, well, minus a negative number is the same as adding a positive number, so that becomes 6. So we have -4 over 6, and that reduces to -2 over 3, -2/3. You can write it as -2 over 3, which would be the same thing as -2/3. Either one of those would be a totally acceptable answer. So, for f of x, the average rate of change from -2 to 4 is -2/3, which does seem to be about the slope of that line that would connect those 2 points. So here it's changing a little faster, here it's changing almost not at all, it's super slow, fast again, and then it reverses and goes the opposite direction. I don't care about those individual points, the average is just the whole darn thing. Next up, algebraically, g of x. If I want to find out how g of x changes from -2 to 1, what I'm going to do is consider this same idea. I need my final output minus my final input over my, final output minus initial output over final input minus initial input. And so the way that we can think about that is we can say this is going to be f of my final number, which is 1, minus f of my initial number, which is -2, all over final minus initial, -2. This bottom part is going to be super easy. 1 minus -2 is just going to come out as +3. But the numerator is going to be complicated because the numerator is going to be based on this function. Oh, I said f's. Those should be g's. Think, Olsen, think. All right. Yeah, the function's name is g. So g of 1, I can actually do this in my head. 1 cubed is 1, minus 4 times 1 is that. So it would be 1 minus 4 would be -3. So that whole thing evaluates to -3 minus, and guys, I promise I can't do this in my head, so I'm going to actually write it out. -2 cubed minus 4 times -2. All right, so I'm going to keep the -3 out front, minus the -2 cubed becomes a -8, minus 4 times -2 is going to be the same as negative times negative is a positive, so positive 2 times 4 is 8. Hey! So I get negative 3 minus a negative 8 plus a positive 8 is just going to be a 0 over 3, which means that my very final answer for this, negative 3 over 3, reduces to just negative 1. And if you want to Desmos that, does that even show up? Oh, just barely. If you want to Desmos that and prove it, make sure that it works, you're welcome to. But this is the general idea, is that you're taking rise over run. You're taking output values, y's or g's or f's, and dividing them by input values, your x's, the whole range that you're doing this interval over. This is a little bit confusing, so watch it again, and then if you've watched this twice, raise your hand and ask for help.